Okay, here we go. We're going to go ahead and take a look at writing out chemical formulas with ionic bonds. Hopefully, if you listen to that first tutorial, you understand that when we see calcium, I right off the bat understand that calcium is in group 2 and it has 2 valence electrons. I look at fluorine and I see that fluorine is in group 17, which means that it has 7 valence electrons. So in your head, you have to be thinking, is calcium going to give away those 2 electrons? And the answer is yes. It's either going to give away 2 or gain 6, and it's much more difficult to gain 6. So in giving away 2, it's going to write out here, it's going to give away 2. Now, that means it has a plus 2 charge. Fluorine, however, has 7 valence electrons, which means it is going to gain 1 electron so that it has that complete 8. Since it is gaining an electron, it's going to take on a negative 1 charge. So we look at this as a calcium who has a plus 2 charge and fluorine who has a minus 1 charge. And when you see just that single minus sign, that's the same thing as a minus 1. So now the question is, what ratio do they combine in? Because in an ionic compound, we want all the charges to cancel out. If you looked back at the example that I did earlier with magnesium here, we saw that the positive, the 2, and the negative 2 canceled out, which is where I came up with this. Well, here we have a plus 2 and a minus 1. So think about it like this. How many fluorine atoms do I need to cancel out that plus 2? I need to be able to multiply that negative 1 times 2. And now that would give me an overall charge of negative 2. Whatever number you multiply by, that is going to become your subscript. So the final chemical formula would be CaF2. That 1 calcium has a plus 2 charge, and I need 2 fluorines because each one is a negative 1, and I need 2 of those to cancel out the plus 2. Let's look at another example, and please excuse my dog in the background barking. It is a beautiful evening, and he needs to be outside. Lithium has 1 valence electron. And so again, we use those valence electrons to figure out the charge on the atom, and since it has 1, I understand that it is going to give away 1. And since it is actually giving away a negative charge, that is going to take on a plus 1 charge, lithium is. Oxygen, as we said earlier, has 6 valence electrons. 6 is really close to 8, so it is going to gain 2 electrons. Since it is gaining 2 negative charges, the overall charge for oxygen would be negative 2. So I'm going to rewrite that as lithium, who has a plus 1 charge, and oxygen, who has a negative 2 charge. When we write this chemical formula, we want these 2 charges to cancel out. Right now, a negative 2 and a positive 1 do not cancel out. But if I could get this lithium to turn into a positive 2, it would cancel out. And to do that, I need 2 lithium atoms. And so I'm going to end up with Li, 2 lithium atoms, and 1 oxygen atom. And that right there would be my final chemical formula. Let's look at another example. Calcium, who we said earlier has 2 valence electrons, is going to give away those 2 valence electrons, which means it's going to take on an overall charge of plus 2. Oxygen, as we mentioned a moment ago, has 6 valence electrons, which means it is going to gain 2. And it's going to take on a nice little negative 2 charge. Next, I'm going to come over here and I'm going to write out my elements. I'm going to write out what charges each one has. And now when we look at this, we see that positive 2 and that negative 2, and what are they going to actually do? They're going to cancel each other out. So I don't need to change the subscripts on any of these. I'm just going to write this out as CaO. 1 calcium atom, 1 oxygen atom, and those cancel each other out, and so there's an overall net charge of 0. Last one. You can maybe try right now pausing the video and trying this one on your own. If you don't want to do that, then just kind of go ahead and listen along with me. Magnesium is in group 2, and I keep referencing this, but I'm hoping that you're looking over your periodic table. You see magnesium, group 2. What does that mean? That means that it has 2 valence electrons. And we've said that if it has 2, it is actually going to give away those 2. it is physically giving away 2 negative charges, so it's going to take on an overall charge of +2. That nitrogen is in group 15, and this is where I said those group numbers are about to become very important to us. Nitrogen has 5 valence electrons. So again, think about that octet rule. We know that every atom wants to get to 8 in that outer level. So what's going to be easier for nitrogen to do? To give away 5 or gain 3. And in this situation, it would be to gain 3 electrons, which is exactly what it's going to do. Since it is gaining 3 electrons, it's going to take on an overall charge of -3. So let's go ahead and rewrite that. We've got the magnesium that has a +2 charge. We've got the nitrogen that has a -3 charge. Again, we want those charges to cancel out and equal 0, and we can tell right now that obviously they do not. We have a +2 and a -3. And this is where those basic math skills come in. You've got to think, what could you multiply each one by to get it to cancel out? Well, I know that there's a number I could multiply 2 by, and it would get me to +6. There's a number I could multiply 3 by, and it would get me to -6. And +6 and -6 cancel each other out. Well, if I multiply the +2 by 3, the nitrogen by 2, that's going to get me to that 6. So my final chemical formula here would be Mg3N2. So you see how these multipliers end up becoming the subscripts on our chemical formulas here. And you've got some practice on that worksheet that you're going to go through and do. So hopefully after you do a couple of these, you'll see the pattern and get used to them.